Welcome, friends. This is the answers explaining session for task 10. Before enter into the answers discussion session for task 10, I will explain the answer for today's question. This is our today's question, which is from heat and mass transfer. First of all, I will read the question. Consider the radiation heat exchange inside an annulus between two very long concentric cylinders. The radius of the outer cylinder is R0 and that of the inner cylinder is R1. The radiation view factor of the outer cylinder onto itself is dash. What the question informing us is that there are two concentric cylinders of outer radius R0 and inner radius Ri. We have to find the view factor. We all know that view factor as another name of shape factor and configuration factor. Okay, all the three, view factor, shape factor and configuration factors, all are same. We have to find the view factor on the outer cylinder onto itself. Okay, this is not simple problem. Okay, even we can solve it by mind itself. Despite of I have solved this question, I will show you now. Now you can see the answer in the screen. Before solving this question, we shall discuss what is shape factor. Shape factor is nothing but consider one surface, okay, which is emitting radiation. Neighboring to the surface there is another surface. Okay, the radiation emitted by the first surface will be in all direction. Out of that radiation emitted by the first surface, how much radiation reaches the neighboring surface? That is what is the shape factor. Okay, now we can see the answer for this question. You can see the concentric circles, which indicates the concentric cylinders. Inside cylinder, that is of radius Ri, there are two shape factors. One is onto itself and another is to outside cylinder. Because it is inside, from this only radiation is transferring to outer cylinder. Therefore, the shape factor on itself will be 0. And we all know that the sum of shape factor is equal to 1. That's why here the FIO is equal to 1. We all know that reciprocity theorem, that A1 FI1, A1 and A2 here are area, which is equal to A2 FOI. From these we can calculate FOI, that is outer to inner, outer cylinder to inner cylinder, A1 by A2 FIO. We know that FIO is 1, therefore A1 by A2. For a cylinder surface, that is circumferential area, is 2 pi r L. Here substitute this and finally we are getting Ri by R0. Now consider the shape factor for outer cylinder. There will be two shape factors. One is for itself and another is to inside cylinder. sum of shape factor is equal to 1. Therefore we have found out the OI, that is Ri by R naught. Substitute this value, we can get the FOOO, that is shape factor on itself is equal to 1 minus Ri by R naught, which is our answer. Okay, now we can check which option contain this answer. Okay, the correct option for this question is option D. Okay, this is our task 10's first question, which is from general aptitude section. First of all, we can read the question. Dash I permitted him to leave, I wouldn't have had any problem with him being absent. Dash I. You have to think carefully. Here, while reading the question itself, we can understand that the this is past tense. That is, the sentence is in past tense. Okay, and while we looking at the options, also all the options are not past. Only two options are past. Okay, one is option A and one is option D. Have means perfect tense. Okay, therefore we have to concise that the answer will be from these two options, that is option A and option D. Okay, here first option definitely had that, in that there is no confusion. In second dash you can read that this is one, it's not a criteria, it's a one action, that is you have permitted somebody to leave the room or anything, and after that you are saying that I wouldn't have had any problem with him of being absent. Okay, therefore here in the second tense only it is possible that positive, therefore option A will be the correct answer. Okay, therefore the correct answer for this question is option A. Okay, this is our second question, which is from our topic heat and mass transfer. This is a slightly big question, not in terms of tough or easy, in terms of size only. Okay, this is first off, then I will show you the second off. First of all, I can read the question. Three slabs are joined together as shown in figure. There is no thermal contact resistance at the interface. The center slab experiences a non-uniform internal heat generation with an average value equal to 10,000 watt per meter cube, while the left and right slab have no internal heat generation. You can look at the figure that there are three slabs of thickness 1 meter, 1 meter, 1 meter, and the middle slab is generating heat. The value is given as 10,000 watt per meter cube. Then this left side 100 watt per meter square Kelvin. By finding its units itself, we can confirm that the given value is a heat transfer coefficient. Therefore, the from the end of this slab, by means of convection, the heat is transferring. That is why they have given the heat transfer coefficient, and the atmospheric temperature is 30 degrees Celsius. T1, the left extreme face, T1 temperature is 100 degrees Celsius, but the right interface temperature, that is surface temperature of slab 3 is T2, we have, which is what we have to find. Okay. Okay, this is the second half of the question. All slabs have thickness. We already know that from the figure itself. We have found out that thermal conductivity of each slab is equal to 5 watt per meter Kelvin. The two extreme phases are exposed to fluid with the heat transfer coefficient we have already found in the figure itself. The heat transfer in this slab is assumed to be one dimensional and steady, and all the properties are constant. If the left extreme temperature is 100 degrees Celsius, we have to find the right extreme temperature. Okay, this is what the question. First of all, most of the students will do a mistake in this question because sorry, the slide has changed. Okay, we can continue. um, the First of all, many of the students will do the mistake here by seeing the figure itself. If left side surface temperature is 100, similarly it should be right side also the same. The students will be determine the answer by the logic itself. Okay, but it is absolutely wrong in this question. In the first half of the question I have said that non-uniformly heat is generating, then how it will be equal? That is the key word in this question. Okay, now I have solved this question. I will show you now. Okay, you can see the answer in the screen. We have to know the basic formula here, that is how much heat is generated here will be the equal to the amount of heat leaving the system. That is what here the formula is. That is heat generated is equal to heat loss through convection process at 1 and heat loss through convection process at 3. And we can heat generated for whole surface of slab 2 will be 10,000 into area into which we didn't know area because we only know the thickness. Okay, keep it as it is. Now you look at the HC1, that is convection. We know that by Newton's law of cooling the formula is HA T1 minus TA. Similarly here for slab 3, from this Hg, that is total heat generated, is equal to Hc1 plus Hc3. By equating these two, we can find the temperature of the right side surface. Okay, we all the values are known except T3. Well, if we solve, we can get directly the temperature T3 value is 60 degree. According to my derivation it is T3, but according to this question it is T2. Okay, don't confuse it. Okay, therefore answer is 60 degrees Celsius.